This, and the other learning resources in this course have been made possible by funding from the European Commission's Erasmus Plus program.
In an infinite loop. So welcome back in this pre-last session for photogrammetry. The thing that we are going to discuss today is, okay, let's assume that we know how to acquire our photos. Let's assume that we know how to make 3D models, and let's assume that we are also able to make georeferenced models. In that case, we have our models in Agisoft, and I already briefly touched this material. We have to discuss how to export these data, how to publish these data, and how to valorize the things that we have been doing. So that's actually the topic that we're going to do today, that we're going to discuss today, how to deal with online and offline publication of 3D models. It's actually quite a brief or short presentation. So it will depend on your preferences. We can either have a more thorough discussion on the status of your 3D models. But if you say, okay, no, I prefer to have the discussion also on the work that can be done in QGIS, we can also cover that that discussion, of course. So there's another presentation available that will make maps in QGIS.
Cornelis, hello.
Hi.
How are you? Can you put the record button?
It is recording.
It is recording. Oh, okay. I'm sorry for the interruption.
Recording to the cloud, it says.
Okay, great. Thank you, and I'm sorry for the interruption.
No problem. Don't you see that I'm recording?
Now I see it. Okay, thank you very much.
Perfect. Otherwise, it would be a conflict of privacy, of course. But I mentioned that we are recording.
Okay, great. Thank you.
Okay, but thank you for the reminder. Anyway. So online and offline publication of 3D models. Before we start exporting our data to all the possible formats, I think it's very good to discuss with your project holder or with the people that require the models, that require the deliverables, to discuss about the formats that they want to have it. Do you want to have it in some kind of an ASCII data file? Do they want to have it in a binary data file? Do they want texture maps? Do they want point clouds? Do they only want the digital elevation models and or the orthophotos? I think that's very important to discuss on forehand before you just deliver them everything that you can deliver. Another very important thing, and I also suppose that it was one of the topics when there was a discussion on GIS, is to discuss about the end user. Like in GIS, if you make a map, a cartographic product, I consider that as some kind of a communication product. You have a message to tell the end user of your map, the end user of your 3D model. And the question is, how will this message get delivered by the end user? Is it something that you will do online, offline? Is it something that you will do via a publication, a conference paper, or is it something that you want to just put in a project report? So the end user, defining your end user also here is quite important. I can, for example, make a 3D model, send it to my grandmother. My grandmother doesn't have a computer. She doesn't have a cell phone. She has a phone, but it's very difficult for her to use it. So I can send her the most wonderful 3D model in the world, in the most wonderful open source data format, but she will not be able to have any interaction with it. So maybe I have to discuss with her, okay, how can I show you my results? So this is very important. What is the purpose of the 3D model? Well, actually, that should be something that you defined on forehand, even before acquiring your data, before planning your data acquisition in general. Is it something that you just want to show to the public? So you make a 3D model and you want to say, okay, I've been there. This is how wonderful your cultural heritage is. And we want to publish it on a general public website. Or is it something that you will send to an architect or a civil engineer or an archaeologist, where the specialist will use your data for measurements or for further analysis? Like, for example, if I make a 3D model of a landscape, The finality of that product will be different if it's just for ecological analysis or for hydrological analysis. It will differ, the resolution will differ, and also the appearance of the model, of course, will differ. Online and online, online or offline, I think that's also obvious. Is it something that you will just put on a USB stick and give to the end user of your model, or is it an orthophoto or a DEM that you will publish using GeoServer or MapServer, and that you will work with some kind of a map interface or map interface for the publication of your model? Or will you use online visualization tools like JavaScript-based visualization tools for point clouds and or for 3D models? And various of these topics will be discussed in more detail in this presentation. So here is just an example of the different deliverables that you can generate using Agisoft. We already covered some of them. Let's start with point clouds. So point clouds, I have, to be honest, I've never exported point clouds in the OBJ file format because it's not very convenient to use OBJ. PLI is a better way of storing your point clouds, because the problem is that you have with a point cloud. If you go back to, or let's go back to a sample project. So this is a project that I did last March, just before the health crisis in Ethiopia. This is a point cloud where I have 134 million points. So imagine that I would have to save this file as an ASCII format, so a human readable file format. You will end up with massive, massive, massive point clouds that are just not useful for data processing. The reading will take a lot of time, exporting will take a lot of time, analysis will take a lot of time. So in that case, it's better to work with binary file formats like PLI, and actually in most applications we will be using LAS. It's a standard for point cloud interchange. Most probably you have heard about GML for your spatial data, where you're able to store your geometry and your attributes in a standardized fashion. Well, actually, the equivalent for point cloud data is LAS. It's an American standard that is widely used for topographic point clouds. And the E57, it's not a standard, but it's also a very convenient way to store your point clouds. It also allows you to save attributes like acquisition parameters of your acquisition platform. But this is something that we will heavily use also in the specialist course on laser scanning. Actually, point clouds will be the main topic of our laser scanning discussion, and you will learn how to work with these kinds of data. For visual purposes, most of the time you will have to work with 3D models, so real 3D models where you don't work with point clouds but with triangulated or closed surfaces. Most of the time there is a texture map draped on these surfaces. That's, if you make your 3D models, for example, in Agisoft, and you don't have that many faces, it's very convenient to fine-tune or to post-process your 3D models in Rhinoceros or in 3D Studio Max. And in that case, you can also use OBJ 3ds models. So, 3ds allows you to directly import your results in 3D Studio Max. VRML, more older file format, old standard for 3D interchange in Collada DAA. Actually, to be honest, I put it out here, but most of my 3D models that you will find are exported in Stanford PLI, and I will show you how that works as well. Yeah, we covered this yesterday, orthophotos, DEMs in TIFF, JPEG, with actually two options. The option where the spatial reference, so the metric information about the dimensions of a pixel, where that is encapsulated in the header of your file. So what will actually happen is, for example, you have a TIFF. A TIFF is nothing more than a raster, a matrix, where all the different color values or elevation values are assigned to a certain pixel with some kind of a decoding behind it, of course. And in the header of that file, you will find some meta information about the dimensions of a pixel, the rotation factor, the scaling factor. If you don't have that information available in your TIFF file, like for example, you want to use your TIFF in AutoCAD, as we discussed yesterday. And once again, I would like to thank you for this, this live question. It was a very interesting discussion we had there. So if you want to use your TIFF in AutoCAD, AutoCAD Civil or AutoCAD Map, for example, you need a conventional TIFF file. And with that conventional TIFF file, you need a world file. So a TFW that will result in some kind of a notepad-like file, a text file that will give you the translation, rotation, and scale parameters. And the same holds for JPEG, PNG. What you actually see here is one of the results of some exporting. Like for example, here, the PLI file, a binary file where you have the references inside this file, you have the references to several texture maps. So TF_4 in the header, you will find a reference to referring to TF4, TF41, 42, 43. And these four files, these four texture maps actually should be accompanied with the PLI in order to have a photorealistic 3D representation of your object. If you're working with an OBJ file, this reference is not explicitly in the OBJ file itself, so in the 3D model itself, where you have the different points of your triangular model, the faces of your triangular model, and all the edges in the model itself. But it also comes with an MTL file. And in this MTL file, the relation to the different texture maps is laid. So these files, OBJ, MTL, and your JPEG should also always be in the same folder if you want to use conventional offline publication of your data. So let's go in a little bit more detail on offline deliverables. If you give me 5 seconds, please. Schat, is er een probleem? Ella? Is alles in orde? Okay, so thank you. So if you go a little bit more detail about the offline publication, the first thing I would like to show you is how to export dense point clouds. I briefly discussed that yesterday. I go to the project. This is the project where we ended yesterday. So I have my 3D model. I have a dense point cloud here. So this is my dense point cloud. And imagine the situation that I want to use this dense point cloud in point cloud processing software like Recap or Cloud Compare or Cyclone. I can go to File, go to Export, Export Points, and then the list that you just saw here in this slide here, OBJ, PLI, LAS, and E57, the same list you will also find here. You see that there are many export options for point clouds. And most of the time for point clouds, I will decide to use a PLI, LAS, or E57. But it definitely depends, or heavily depends on the end user of your data. So I will select LAS. I will save it in my on my desktop, and I will say, for example, gates_PC from pointcloud.las. Then I'm directed to this screen. In this screen, as with the orthophoto export, I have the option to decide on or to select my my coordinate reference system. In this case, again, it is a local coordinate reference system. For example, if I'm working here on this project, so this again in Ethiopia, where we used, let me see, these were all in WGS for the cameras and UTM-37 north for the ground control points. And in that case, I can actually decide, okay, I want to export my entire model to WGS84 or to UTM or to the local Ethiopian coordinate reference system. In that case, it's just a matter again, just give it a random name. And here I can select all my coordinates or coordinate reference systems. But let's go back here. I'm working in a local coordinate system. I can shift my point cloud. So if I know the primal point, the point of gravity of my point cloud, I can use that point for translation of my entire point cloud. What do I want to export? Of course, I have two options here, the sparse point cloud or the dense point cloud. Remember that sparse point cloud is just a 3D representation of all your matching points. And the dense point cloud is the real reconstruction of your geometry. So I will select my dense point cloud. I will export my point cloud, including the colors of the point. If I disable it, I will just have white points. Binary encoding, of course, because that's the case with the LAS file. And if I have very large point clouds, I can also make blocks. So divide my my point cloud in smaller portions. So it's now exported, and in that case, I see here on my desktop gate_ps.las. Let's open it in Cloud Compare. And then I can go to my point cloud, open it, and then here is my point cloud. And in that case, I can actually continue processing my point cloud outside IDsoft, but inside any other point cloud processing software. By the way, if you're interested in using Cloud Compare. Cloud Compare is an open source software for point cloud processing, and we will put a lot of time on working with this open source software in the next specialist course. So if you're still doubting to attend to the course on laser scanning, maybe this can convince you, because from my perspective at least, Cloud Compare is extremely powerful for point cloud analysis. So definitely useful. For example, just to show you very briefly, you can select your point cloud, make DEMs quite fast with it. For example, if I want to make a DEM with a resolution of 1 centimeter, but it goes extremely fast. But we will cover this in more detail in the next specialist course. But just know that it's possible to export your point cloud, and this is then the base or the starting point for the further analysis in Cloud Compare. Same also holds for other point cloud formats. So if you haven't done so, here's a reference to the software where you can download Cloud Compare. This is also something that I discussed yesterday, so I will just do it again for sake of completeness. The exporting your data to an orthophoto and a DEM. You go to Export, Orthomosaic, Export JPEG, TIFF, PNG. I can select my resolution. Always go to the minimum value, like the minimum value that I have here, 2.3 millimeters, or lower. So I can go to 5 millimeters, 1 centimeter, 50 centimeters, but I cannot go to 1 millimeter. In that case, like I said yesterday, I'm just making up new data, and it's just redundancy, fake data that's not very useful. What else is important here? Yeah, if you're working with very large areas, you will have to select big TIFF file. That's, for example, something that I had to do here in this case. In this case, for my airborne acquisition campaign, I had an Orthomosaic covering 29,800 pixels by 25,266 pixels. If I make it a conventional TIFF, I will end up with very large files, just linear files that are very difficult to index. If you use, in this case, a big TIFF file, it will increase the rendering. It's actually some kind of a pyramid structure that is incorporated in your TIFF file, and it will help you to including this one, of course, it will help you to speed up the visualization and analysis of your TIFF. So you can just press it here. Yeah, the compression, loosey or looseless compression. And if you want to use JPEG, also have the option to decrease the quality of your JPEG here. Let's call this ortho of gates underscore ortho. And in this case, I also have multiple exporting options. You see TIFF, JPEG, GP2, PNG, or BMP. Most of the time, conventionally, it's used TIFF, but you can also use the other formats, including georeferencing on it. I will directly do the same with my digital elevation model. So also, I will set my resolution to 5 millimeters. The same holds here. I can decrease my resolution, but it's not useful to increase your resolution. Same also here for the TIFF. The reason that I don't have the option to export as a JPEG is that TIFF actually allows you. Now let me put it differently. If you have an orthophoto, you actually have 3 or 4 layers or bands. Put it in a proper words. A band for the red band, a green band, a blue band, and possibly an alpha band. And these 4 bands, or the values of these 4 bands, will result in a composite, in a real true color composite. Or if you have multiple bands, like with satellite imagery, you have Landsat data that included near-infrared or thermal. These data are all stored in different bands. You make composites of it, and that's how a TIFF works in that case, or a JPEG. When working with a DEM, we don't have image information, so we don't have a value that goes from 0 to 255, for example. But we have a floating point. We have a decimal value, and the decimal value is assigned to a certain pixel in our matrix. So we have a continuous surface, or an continuous surface, and JPEG does not support that way of saving data. So we have to work with additional file formats. And that's why in this case, we have some different exporting file types as well. The TIFF will allow you to save your floating point, your decimal values, and some ASCII-based values, so where you have a text file with all the different values for all the different pixels. And I think, but I'm not sure about it, I think a bill is also a binary format, but I've never used that, to be honest. So I'll just say gates DEM, save, it goes very fast, obviously. And what I can do now is go back to my desktop, and I see here in this case an orthophoto and a DEM. I can click on my orthophoto and open it in my standard image viewer. That's no problem. But of course, if I do the same for my DEM, because of the fact that I'm not saving conventional RGB values or non-conventional color values in my digital elevation model, I don't see anything. And even if I would see anything, it will be just a white color with a black surface around it. So if you generated a DEM, you open it and you don't see something that looks similar to what you see here, for example, then it's all because of the fact that in this case, we are working with decimal values with appropriate renderer behind it. And in this case, yeah, we're just expecting, or Windows is expecting RGB values, but they are not here. They're obviously floating point values. So what I can do in this case, in order to open it, I have to make a new project. Die gaan we kwijtspelen, discard. What I will do now is I will just take my rasters, my DEM and my orthophoto, put them in my QGIS. Like I said yesterday, by default it's in WGS84 in my case. So I will change it to the Belgium format. and do it again. It's a mistake that I also made yesterday. I actually always make that mistake. Voila. And now in QGIS, I can use my measurement tools. I can start digitizing. A very interesting remark, still in, just a moment. Ugh. Very sorry. A very interesting remark of yesterday, from yesterday, was the fact that, of course, in AutoCAD, it is very convenient to digitize. Personally, I would also use AutoCAD for digitization. So if you have, for example, here this facade and you want to draw horizontal, vertical lines, perpendicular lines, parallel lines, from my perspective at least, and I was very happy to hear that at least some of you agree on that AutoCAD is very convenient to do so. But obviously you can also use the editing tools in QGIS, or if you're using ArcMap, you can also use ArcMap the same way. Just import your orthophoto, import your DEM, and you have your you have the option to start digitizing. If you want to use AutoCAD, like I said, in that case you will have to generate a world file. Maybe I will just show it to you. Here you have to set world file, Gates, ortho, photo, AutoCAD. I will load civil. Meanwhile, so yeah, for importing and exporting digital elevation models. An interesting thing that is very easy to do in GIS environments, in both in QGIS and in ArcMap, and that is not so convenient in AutoCAD, is the construction of profiles. Obviously, you can generate profiles in Civil 3D or in Map 3D, so I will not say that it is impossible. You can just use the AutoCAD tools to prepare these data. First, before I explain that, I will just import my my map data. Map insert. I will go to my orthophoto with the TFW file. And now in this case, it will say, okay, I have a source. The source includes a world file. The world file, for sake of completeness, let me go to my, I have to include it here. Well, the thing that I wanted to say here is that if you have a world file, it automatically detects your insertion point, your rotation, and your scale parameters. So I can just press OK here, zoom, extend, and here is my orthophoto. And if I do a measurement here, for example, from here to here, I have the same metrical value as I would expect in my GIS environment or in Agisoft itself. So in that case, I can just start drawing lines, perpendicular features, and all that stuff. So it's definitely possible to do that in AutoCAD Map or AutoCAD Civil. If you're working in regular AutoCAD, I would advise you to make a polygon first. So use QGIS to make a polygon around your orthophoto, or at least defining the bounding box of your orthophoto. Then extract that boundary, import it in AutoCAD, and then you can use that rectangle to scale and translate your orthophoto. The finality is the same, but you're just not using the world file directly in AutoCAD. And the world file that I was referring to is actually this file. So this is definitely required if you want to use your orthophoto in AutoCAD. And if we look on the content of it, what you see here zoom in a little bit, is the resolution. You see here 2.3 millimeters. These are all in meters. And if we look here back in Agisoft, it's the same value. Oh, no, because this is another no, it should be the same. 23. Yeah, it's the same. I'm sorry, it's the same resolution that I have here. So that refers to this one. And I have here some a resolution in X, a resolution in Y, and a translation parameter. And this is the rotation of my values. That should be included in your folder, in the same folder as where you have stored the orthophoto and or the DEM. A very interesting thing to do in QGIS, and once again, it's also possible in AutoCAD Civil, but I prefer to do it in AutoCAD, just because it's a very cool feature, is use the profiling tool, so terrain profile. And if you take your DEM, for example, here, I have my DEM, then it's very easy to make profiles over your terrain model. And you can export these models to just graphics, so DXF graphics, SVG or PNG, or even export your data with the resolution of your original DEM and then work in Matplotlib, in Python, or in Excel, or any other numerical processing program to fine-tune your profiles. So this is actually quite a convenient and easy way to work with digital elevation models. Of course, we can do the same here for our gate. So if you have a gate here, we have a gate here, obviously. You say, okay, let's make a profile from here to here. And in this case, we actually have a flat projection of our facade. We do the same in this direction, for example, like this. So here is the door itself. Here it goes up, the relief, and this edge, and the start of the cross. So you can use that for further object analysis. Quite interesting. So yeah, orthophotos and DEMs, and then you can of course further post-process it in QGIS. This is something that I already showed you yesterday, the use of 3D models for PDFs. What I didn't cover, I did cover that the exporting your models for real 3D models. So for example, if you have a viewer like MeshLab, go to MeshLab, this is open source software, I think from an Italian research institute, and it allows you to do visualizations of 3D models and also some analysis. You can use the software for profiling, for remeshing, for do some calculations on it. Quite interesting software. And it also allows you to import quite a lot of 3D file formats. So let's, for example, make a 3D model in PLI format. With textures, we want to export our textures as well, binary encoding. And the result here is a 3D model. And like I said, we have a texture map in this case. Only one, because we're not working in exactly the same model as the model that we had yesterday. So I can just click it. And then here I have my 3D model. If you go to open here, import mesh, you will indeed see quite a long list of possible import formats. So even if you have worked with 3D Studio Max or with Revit, I think you can export your data to FBX, point clouds, with or without normals, but these are just ASCII data, so I will definitely not recommend you to import large point clouds using this functionality. But just on the fly, if you feel like experimenting with it, there are some formats that are both available, exporting formats that are available in Agisoft and importing functionalities that are available here. So quite an interesting way to share your projects. So that's for MeshLab. Yesterday, I also showed you the possibility to export your model through to PDF. And of course, the processing reports also demonstrated yesterday, and I think that is very important. So that's why in the exercises, from time to time, I really explicitly ask you to upload these reports, because it gives you a very good insight on the content of your 3D model. So that's for the offline deliverables. But on the other, if we discuss about offline modeling, we also have to discuss about online deliverables, which is a little bit more tricky and less convenient if you're not familiar with online environments. So I will also discuss a very easy, straightforward way of working with online 3D modeling. And I will just give you a sneak preview on some more advanced ways of publishing your data. And the first application that I would like to show you is Sketchfab. Sketchfab is a very interesting platform for sharing 3D models. So the way it works is actually you can, if you have a 3D model, and in the free version, the 3D model should not be too large. So it has a certain limitation, but it allows you to publish 3D models. So for example, here a couple of years ago, we did a data acquisition in the Swiss Alps, or at least I was not there, but my students were there. They did a drone flight on the permafrost area somewhere in the south of Switzerland called Lutzanetsch. And the data that has been acquired with a drone was processed in Agisoft, and from Agisoft they made a 3D model. And in the 3D model, you can actually use annotations with some more information about certain areas of your 3D model. So a very convenient way of sharing your 3D model with the public without the need of installing plugins or any additional software. So for publishing 3D models, very straightforward to do that. You need an account to access these data. And this afternoon, I generated a new account using my email address or my Heritage email address with a password that I will share with you. So I would really like to welcome you to upload your data there that you acquired within the framework of this specialist course. It will also allow me to evaluate your 3D model. So it's, I think it's a win-win situation. Just showing the 3D models of the workshop with the public and evaluating your models in the meantime. But of course, feel free to make your own account and upload your own 3D models on the platform. It's possible to work with keywords to make your models more easily accessible and findable on the internet. And it's also very interesting to use this platform for personal or organizational, as a personal or organizational 3D portfolio. So for example, I made my own platform. So CSTAL is the name of my username. And if I click here, I have various 3D models that are clickable. So for example, last year I was in Istanbul. I hope that it goes a little bit smoother than this afternoon. It goes well. So for example, in the Hagia Sophia, this is the ceiling of the Emperor's Hall. I think it's called the Emperor's Hall. I took my cell phone, made a lot of photos, and you can just upload your result on Sketchfab and have interaction with it. So I'm not even logged in on my own account at the moment. But you see that the quality that you can obtain is quite interesting. Something else that can be shown here in this context, yeah, these masks. Voila, the geometry and also the texture mapping, also taken with my smartphone. So it's very easy to have access with your 3D models. Interesting in this case also is the fact that if you upload your 3D model on Sketchfab and you access these models on your cell phone, it allows you to have interaction with your models in virtual reality. Obviously, that won't work in this case because we're working just on a flat screen. But even if you have a Google if you're using the HTC Vive virtual reality glasses, even the Google glasses, you can just take your smartphone, put it in the Google Cardboard. Sorry, not Google Glasses, Google Cardboard, I'm sorry. If you have a Google Cardboard, you can use Google Cardboard, plug in your smartphone, and you will have, for just a few dollars, you will have a virtual reality experience just by clicking here and looking at your 3D model. It's a very interesting application. Even point clouds can be accessed or uploaded. So this is a simple point cloud that was acquired by one of my students in PLI format, and you can just access it and click on the content of it. Another nice example is there's a question. Let me try to access the chat functionality. Google what? Google Cardboard. Thank you for your question. Google Cardboard. Let me look it up for you. So I did something like this. This is a prefab model. In this case, it was 650. So the idea is that you really have made out of cardboard glasses. I think I have one of these in plastic in the attic. So during the break, I will try to recover that one. And the idea is that you see it here. You actually have an opening. You can open this one, put your cell phone here, and then through these glasses, you can you actually have a dual screen. If you give me 5 seconds, I can try it on my own cell phone. Sketchfab. Install. For example, I hope that it's fast enough and that you can see it. So if I take a mask, it's being loaded. I hope you can see what's happening. And otherwise, I will just advise you or encourage you to have a look at it yourself, because this is really cool stuff. Yeah, voila, it's working. So what you actually, I was just taking it in the wrong, I have to rotate my, my laptop now. Otherwise you will not be able to see it. Yeah, voila, no, yes. I hope you can see it. So imagine that this was, this is quite tricky. Imagine that this is inside your Google Cardboard. So the thing that you see right here, let me enlarge my screen a little bit. So stop sharing. Voila. This is actually what you would see in your Google Glasses environment. So you can really have interaction with it based on the orientation and the positioning of your smartphone. And you can just have this experience for a few dollars or a few euros using a Google Cardboard, having interaction with your cultural heritage or with your 3D model in general. So thank you for your question. Let me share my screen again. And there are many, many things that you can buy on the internet for that. At my institute, we were even thinking about buying many of these classes with our own logo. So there are some publishers where you can order these kinds of glasses for a very limited amount of money if you do it in bulk. And then you can use your own logo. It's a very interesting thing for publication and data valorization, of course. So just your own, like something like this, for example, with your own logo. Some interesting for branding, of course. Another example of that is the geography department. Officially, I'm not working there anymore. I'm a visiting professor. So this is the example of the Col du Sanetsch. So the Alpine area where you have some clickable content, and you can actually guide your user, your end user, through the model. This is a model that I made myself. Let me find it. Where is it? It's not this one. Platform. Yeah, this one. So this is actually, I think it was my first upload on this platform. It's the archaeological site of Etzna in Mexico. We made a 3D model of it in cooperation with INA Campeche and UNESCO. And also in this case, the user, the end user, is guided through the entire model. And as you can see here, it's also compatible with virtual reality. So it's quite cool stuff that you can do here. And also, I cannot keep myself from sharing that with you. The model that I showed you in my first presentation, so the Mercator Globe, is also in limited resolution, is also accessible here. So you can just have a look on the Mercator Globe from 4051. So how can you work with Sketchfab? Well, it's actually quite easy. The first thing you have to do is make an account. So as with all these kinds of platforms, you have to make an account. You can make your own account, but I would really like to encourage you to also use the account that I prepared for you. I will send you the login and the password very soon. And then after that, it's quite easy to upload your own model. After uploading your model, you can give your model a name, a logical name, of course, a little description, a category, and some tags. These tags make your 3D model more discoverable on the internet. And then optionally, you can change your settings, your radiation parameters, or the radiation parameters, the scale of the model. So if you want to have it very large or very small, you can reset that, the starting position for the observer if he's using virtual reality. The annotations can be set. It's something I will not show you in much detail because I think it's just a matter of experimenting with all these parameters. So add annotations, and then you can publish it, share the link with your project stakeholders, and encourage them to use the model in virtual reality. I can show you the interface of it. So if I go back here, so now I am signed in as Heritage. So my username is c.stal@heritage.org and the password is summer school, but I will put it in the WhatsApp group. If I want to upload a model, you just go to upload. You can select your 3D models. I go here and I select my PLI file and my JPEG. I can upload it here. Upload files, should go very fast normally. And then here I can set my title. So Ottoman, fountain, Nafplio, category, cultural heritage, for example. Oh, there's a question. If you are creating, as you say, some models with your smartphone during travel, can you just upload them on a platform like Sketchfab without informing the site manager? Is this the same thing as, for example, taking a picture of a heritage site on your holiday and putting it on Facebook in terms of privacy? How do you go with it? That's a very good question. The sites that are published in on the UGent account, so the account that I show you for the Department of Geography, in that case we had explicit permission to fly a drone, to make photos, and to publish these data. So in that case it's all set. In case of my personal account, so if I go back here and I go to my personal account, that is totally for personal means. So even the 3D model that I showed you, it is not. It's published as if I would make a photo and put it on Facebook, for example, like you correctly mentioned in your remark. But it's an interesting topic. I'm more experimenting rather than in privacy and rights issues. So maybe any of you can clarify this, because for example, I'm not fully convinced or aware of the fact that you can, if you make a photo of a Greek temple, for example, if you're allowed to put it on Facebook. If that answer is yes, then if you make a 3D model or a photo, there's no difference in that, I think. Which types are supported? That's a very good question that is hopefully more easier to solve. If you go to uploads, voila, here's your answer. FBX, OBJ, DIA, Blend, STL, and many others. So let's click on many others. And here you have an overview of all the file formats that are supported by Sketchfab. So recommended formats, OBJ, that we also used here in Sketchfab. This is still processing, so I will wait for that a little bit. A very interesting thing, also a very interesting feature to do, is that if you go to your account in Sketchfab, so let me go back here, cancel, and go to, I think, here in the settings. Yeah, under settings, password and API. In this case here, you will find every user has an own API token. And you will say, okay, what can I do with an API token? Well, if you go back to Akisoft and you go to File, Upload Data, you will have the option here to upload your data directly to Sketchfab. So the thing that you have to do here is say, okay, what do you want to export? Your sparse point cloud, dense point cloud, or your 3D model. So let's say we want to export our 3D model. You give it a name, a description, and in this case here, you have to copy paste. You have to copy and paste this API key, some kind of a security key that you have here. And then you press OK, and the model is automatically exported from Archisoft to the Sketchfab platform. So quite easy to work with that. Here it's still working on.
Elise,
Yeah.
there is a question from Jane. It was before the Thomas one on the chat.
Ah, I'm afraid I missed that. I'm sorry. Let me see. Do the virtual in museums also. I'm not fully sure about that. I've seen some things, virtual museum, Sketchfab. I've seen something in newsletters. Actually, you can use the platform as some kind of a virtual museum, but also very interesting. And I really hope that it answers your question. If I go back to my own platform, if I take, for example, this one, is that you can also embed your 3D model in your own website. So you just take here this code. This is HTML code, and you can actually import your model directly in the website of your museum or your website or anything like that. So I hope that answers your question.
Papa, ben je gedaan?
Ah, ik ben bijna aan de pauze, dus dan kom ik eventjes helpen. So meanwhile, the 3D model is ready. I will minimize this, say save. It's saved. And what I actually can do now is look on my model. Voila, here's the model of the facade. I can zoom in. It's not the most nicest model ever made, but still you get the idea. I will remove this instantly again because also the orientation is not very good. I can modify the orientation in the settings. So edit 3D settings. Ah, voila. And now I can actually modify the field of view. I can modify the lighting conditions. I can change that or add annotations. Let's say, for example, this is something, and double click here and say this is something else. And then it will actually go, you can actually go from one annotation to another annotation. Now I'm hoping that I can, yeah, this is better. Now I've rotated my my axis in order to have a more natural interaction with my 3D model. And if I save this, I exit it, and then I will go to my account. There is, voila, only one model that is not published yet. Then here you can find your model and you can just go from annotation to annotation. But there's something wrong with the, also here with the orientation of my axis, so I have to modify that one. Yeah, just before the break, I will just briefly mention that if you don't want to upload your 3D models to a server like the Sketchfab server because of privacy reasons or because of publication rights or because of anything else, because actually the same regulation on privacy also holds with Sketchfab as they do for Instagram or Facebook. Once again, I'm not a real expert in it, so I'm really looking forward to have a discussion about it and get more knowledge about it. So if you want to do it on your own server, you want to publish your data on your own server, there's some very interesting JavaScript-based frameworks that you can use. This is, for example, a website including offering an open source JavaScript library for online publication. So if you have a 3D model in PLI, you can just convert it, index your 3D model, and then it's very easy to upload it in your own server. Just to give you an example of it. No, I will not give you an example. I cannot give you an example of it easily. But if you want to have more information about it, yeah, you have to, a viewer, a converter, and then you need a server to upload your data, build a website around it, and it works quite well. Actually, the examples that I already showed you in previous presentations also use this website, 3D or this engines. Go to geodesagent.be. Just a moment. Let me stop sharing because I have to log in. Voila, I'm logged in. So if I go to a 3D model, let's take this one for example. You see that it's loading quite fast. You can have very easy interaction with your 3D model. And the thing behind this is just a 3D file and an XZ file that is accessed via a web interface. In this case, it's a server-based interface using PHP, but that's something that's beyond the scope of this workshop, just to show you that it's possible. The other thing that I'm demonstrating here, A-Frame, is also quite a cool example. It allows you to work with 3D models as well. So the same way as the 3D Hub for own server applications, or Sketchfab if you just want to use other commercial servers for that. A-Frame has a very interesting application, or very interesting application, because it does not only allow you to show 3D models like the other examples, but in addition to that, it allows you to have access to the model in virtual reality too. So I hope the loading goes a little faster than it does now. Let me see what's happening. Not much. So now it's loading the model. I will just download it for a little moment. It can take a few seconds. So, conventional 3D modeling, interactive interface with the ability to measure distances, surfaces of areas, etc., and or virtual reality applications. You see, it's still loading. Models are quite heavy. Something that we will discuss next week, if you're following the specialist course on laser scanning, is an open source viewer for point clouds. Actually, I already demonstrated this application, and I think it's very cool to show it to you right away, because I have a very nice thing to show you. Voila, here's, this is A-Frame. So A-Frame has the ability to use virtual reality. So you see here these columns, and if the user aims with his glasses to one of these columns, he's actually teleported to in that direction. You see what I'm doing now? So this is my 3D model acquired with a drone last September, and the user can go from one column to another. And actually last December, we were promoting this project, and here you see the bishop looking on his own cultural heritage. So a very interesting way to demonstrate the use of technology for these kinds of projects. PO3. So if I go to point clouds, yeah, voila, here's point clouds. If I go here to this is a thing that I'm loading on my own computer at the moment. So you're looking at the archaeological site of Eleusis in Elefsina. That point cloud has been intensively covered by laser scanning, of using laser scanner a couple of years ago. And we built a web interface around this point cloud to have access to this huge amount of points. So at the moment, you're looking at millions and millions and millions of points that you can use for further analysis. And next week, we will also use this point cloud for some visualization, data cleaning, stuff like that. The engine behind it is PO3. It's actually an also open source engine that will allow you, allow you first to convert the point cloud in LAS format to an indexed file format, and then use it in a Java-based environment or JavaScript environment. So you don't need any plugins to interact with these point clouds. Voila. I would like to propose a little break, unless you have questions for now. Recording, voila. So we're recording again. So this presentation is about publishing your orthophotos and DEMs using actually the same techniques as you have seen in the GIS course. So using image-based 3D models in GIS. So first of all, like I already said, cartography is the art and science of graphically representing a geographical area using usually a flat surface such as a map or a chart or a 3D model, especially when you use 3D models in a metric fashion and you assign annotations to it or 3D databases on it. And it's a way of communicating. So you have a message, and with a map you can actually communicate about the content of your spatial phenomena, like cultural heritage in this case. So there's a very interesting schema from my previous promoter on the university. It starts with a reality. You do a disciplinary analysis. So for example, you have your reality, and the reality is some kind of a cultural feature, a heritage object, facade, or statue or something like that. And then the disciplinary analysis is actually making photos of it and converting these photos to 3D models, or you use a topographer to measure the dimensions of a certain facade, or you make a 3D model based on laser scanning or something like that. And the result of that is that you actually generated a spatial model, so a spatial representation of the reality. But that's not finality of the cartographic process. You need a cartographer to convert this spatial model in a map design. So the cartographer will perform a cartographic analysis on it. And you need a cartographer to do a graphical syntax, or to apply graphical syntaxes on this map design in order to generate a map. And then in this case, so you go from reality to a map. Then you need the end user. The end user will do some map reading. He will interpret the map that you've generated. And based on that, you have a perception. And under normal circumstances, if the communication from the map via the end user has went smoothly, the perception that the end user will have based on reading and interpreting the map, will correspond to a certain extent with reality. Many times when you look on papers, newspapers, or glossies or something like that, you will see something that looks like a map, but it's actually not a map. And it's very important to, if you make a map, that you implement some of the cartographic rules in order to make a distinction between a map and just an image or illustration of a cartographic phenomena. And there are some rules. They are presented here, but they are in Dutch. I don't have an English translation of it. The source is Ghent University Department of Geography, where it actually says, okay, if you want to use or if you want to publish a map, make sure that your alignment is set correctly. That if you make polygons, lines, and points, that you play with the coloring, that the objects are clearly distinguishable from each other. That you have to use your side elements. So, of course, when you publish a map, it should be accompanied with a scale, with a north arrow, with a grid system, legend, just to make sure that the map can be understood correctly. Also very important is that if you implement information about the dimension of your spatial phenomena, that you implement SI units, so Système International units, so work in a metric system, or if you're from the States, use an imperial system, but use some metrical system. A projection system is always advised. It's always good to work in a certain projection system. A resolution also very important, especially if you want to publish your maps in hard copy, or also in online for online publication, that you use a sufficient resolution of your map. This slide gives you some information about the requirements of a map. So what should be included? Always include your title, not just put a map on a piece of paper, but show the user what is on the map. In many cases, it's always advised, also advised to add a legend. So for example, if you make a map of an archaeological excavation, or if you have a 3D model of an archaeological excavation, you made an orthophoto of it, and you start drawing lines, these lines should get a certain meaning, not just lines, but maybe stratigraphy or boundaries of the excavation plot or something like that. A data source, if you're working with external data, or if you want to show the source of your data, a header, north arrow, scale, date and an author, spatial referencing, and of course, if you want to make a plot of your map, also include, it's frequently forgotten, a margin, because a plotter or a printer cannot print until the edges of your piece of paper, but you need a margin to make your print feasible, and not lose any information on the edges of the map. So making maps in QGIS, you don't necessarily need a specialist on GIS, or to be a specialist in GIS. Even with very rudimentary knowledge, you can actually, especially with the knowledge that you get from this slide and from these elements, it's very easy and straightforward to make a map in QGIS. Make a composition and export that composition to a PDF or something that you can send to your plotter. In this case, it's very important, especially for the people working in AutoCAD, also to make the distinction between real-world coordinates in your map viewer. So if I go to my CAD environment, to my GIS environment, and I load my my orthophoto, for example. I'm doing it again. I recently updated my GIS environment, and in my previous environment it was reset to Lambert 72. Now, anyway, I have my metrical orthophoto here. The measurements that I do here in this viewer, in my map viewer, these measurements are in meters, are in real-world coordinates in this case, as a function of the scale in this case. But anyway, this is my model space, or comparable to what you would know in AutoCAD as a model space. As soon as I click here and I go to my paper, I'm actually working in my paper space. So if I draw a map here, or I make a map frame, map view actually, then the measurements that I have here are in millimeters, referring to the dimensions of my piece of paper. That's very important to keep in mind, that your analysis will take place in your map viewer, and your cartographic fine-tuning or preparing the publication will take place in your paper space, as you would also do, of course, in AutoCAD. So if you, I already also prepared a demo data. You can download the demo data from geo.hoogent.be/heritage/sc. And in that data, you can find a digital elevation model, an orthophoto, and the background derived from Google Satellite. And after that, you can just make a new layout view. And using that layout view, you can actually add certain cartographic elements. So you can add a map, you can add a picture, this for logo placement, possible labels if you want to do that, legends, scale bar, mode arrow, HTML page, so if you want to export or import HTML content, it's possible, attribute tables, it's all possible. So after starting the composer, it's very good to define the shape of your, or the dimensions of your piece of paper. So if you want to plot it to A4, A3, A0, you can fine tune that in the page settings. Also, the orientation of your piece of paper can be set. And a very important parameter, of course, is also the export resolution that you will use. And then you can add a map, as I already did. If I go back here and I say layout, page setup, I prefer to reorient my my page. Let's page. For one reason or another, I'm always struggling with the page orientation. I will just make a new page. Portrait orientation. Voila, I'm just adding a new page here. It should be a more convenient way to do that, but it's not working at the moment. So you can add your map view. So for example, I want to have this as a map view. Voila. Then this is my my content. Here I can set my scale, 1:25 or 1:20. And use move content to have a better coverage of my object. Voilà. So let's assume that this is an appropriate view of my object. Something like this. Just a little bit lower. Voila. The next thing that I will have to do, next to having this map content, obviously, is to add a title. But first of all, I would like to go into a little bit more detail about the map properties. So I also showed you that the content itself can be moved using move item content. It's a little bit comparable as if you would use AutoCAD, double click on your viewport and start modifying your viewport. In this case, it's two separated icons that you have to use. So with this one, move item, it's just moving the item of your map view. So I'm now modifying or moving my map view over my piece of paper. Using this one within that viewport, I can actually just modify and change the orientation or the position of my object within my viewport. The main properties are the scale. I can also rotate my my object. So just set a numerical value for the orientation. And if it is required, it is also possible to change the coordinate reference system. So if my source data are in a local coordinate system like the Belgium Lambert 72, and I want to publish everything in UTM 31 North, for example, then it's possible to modify that here. The extents are numerical values of the extent of your viewport. And that's what's mentioned here. Yeah, you can add grids. If you want to add a grid system, modify the grid and say, okay, I want to have an interval of 50 centimeters. So 0.5 in the X direction and 50 centimeters in the Y direction. And then I have a grid corresponding with the coordinate system as used in Agisoft. Of course, you can play with it. Say, okay, 50 is too dense. Let's make it 1 meter by 1 meter. And now I have a grid of 1 by 1 meter. It's also possible to draw coordinates around it. Voila, something like this. I've not experimented with it this far, but I think it is possible. No, it's not possible to increment or to assign a negative offset to your coordinates, which is quite a pity. You can only increase that value. So I will not cover that, of course. Map teams are also possible. So if, for example, in QGIS, you have generated some viewports here. So let me import my DEM as well. Yeah, here's my DEM. Voila. And I can say here under map teams, say, okay, this view is my view for DEM. In this view, I will call it ortho, for example. Then in my map view, if I go back to this page, to the upper page, I can make a new map, for example, this one. I will copy it and put it here. And then back in the main properties, I can say, okay, this view should follow the map team entitled DEM, and this view should follow the map team entitled orthophoto. And in that case, the layering order, if I modify the layering order in my map view, so in the core application of QGIS, it will also automatically modify the view that I have here in this map viewer. Very interesting to keep track of your different map views is you can, of course, rename your map views, which is very convenient because otherwise you will end up with map 1, when map 2, map 3, map 25, which is of course not very convenient. So for example here, ortho and DEM. So the grids, already discussed that very briefly. So the ability to define your own grid with a certain interval. You can say, okay, I want to have solid lines, dashed lines. I will only want to show the crosses, or I want to change the color of my grid system. Most of the time, it's not very good idea to have a very apparent grid system. For my personal appreciation, I prefer to have a smooth grayscale grid system over my map, and also for the coordinates. It's a very good idea to also make that a little bit more subtle. In this case, it's even outside my my map view. So what you can do, for example, to improve the readability and appearance of a grid system is say, okay, let's modify our grid and only have our labels on the left side, not on the right side, not on the top side. And even more, the labels on the left side should be vertically oriented. And even more, I don't like these decimal places. So let's put 0 coordinate precision around it. And now I have my coordinates expressed in whole meters and not in decimal meters. So that's actually what I'm showing here. A lot of parameters that you can modify. It's a matter of practice. Legends, also something very interesting, especially if you're working with DEMs or with vector-based data that you want for where there's a database behind it, where you want to show a semantic data model behind your information. So let me go to DEM, for example, modify the colors a little bit because I don't like these black and white colors. I might go quite fast through this, but I assume that you already had this covered in the previous session. So I will make a nice looking or pseudo nice looking visualization of my DEM. So let's make something like this, for example. Then I can go back here. Update my map. Update. Of course, I have to do that. Of course, I have to update my my view. Voila, now it should be set. Yeah, here we are. So let's add a legend here. Add item, legend, and then I can just put a legend here. Of course, in this case, I have too many labels, as you can also see here. So in this case, if I modify my labels here, say for example, 125, I will remove this one, I make this 1.4, I will make this empty, five, etc., etc., etc. And if I upload or update my legend, you actually see that these values are modified. So it's a very convenient way of modifying your legends. I can auto update my my legend view, and in that case, I will only have the visible ones, or the ones, the features that are selected in my data view. And of course, also in this case, there are a lot of parameters that I can modify: the font type, the spacing, the dimensions, etc., etc. Adding labels, I already said, okay, we need a title. So you can go to map, add item, add a label, and say, for example, okay, I want to label here. Let's call this digital elevation model. We'll modify my font a little bit. Center it a little bit smaller. Voila, digital elevation model. Align it with the center of my map view. And I can put it here as well. And of course, I will call this orthophoto. Voila, so that's how easy it is to add titles. Other options here is the ability to add dynamic labels or dynamic titles. So for example, if you want, it's very useful if you want to have a systematic map series. So you're working on an archaeological site, you make a map on a daily basis. Then you can use dynamic labeling to automatically reset the date of your project. So you can set the date, you can set the author, you can set layer property type, so the coordinate reference system. It's also possible to do it in a dynamic fashion. Here's an example of dynamic fields. So for example, to date, give me the to date now, give me the moment as it is right now. So here I have my author, and under it a field referring to the current moment, the current date. And you can use it as a dynamic field in your metadata of the map. And then, yeah, by using that and using more of these functionalities in add item, add a north arrow. It's not very useful, of course, for a facade plan, but if you're working in an airborne application, a north arrow can be very convenient. A scale bar. Let me show you how to add a scale bar, add item scale bar. So voila, by default, it gives me one black and one white region. You can modify it. You can modify it to the left, to the right. A fixed width is possible. So take 4 entities with 1 meter equidistance. Then I end up with 4 bars, 4 sub bars with dimension of 1 meter each. And also in this case, you can modify the font and the font size of your scale bar. If you want to add more pages, so in this case, I initially had 1 page, but after a certain moment, I added another page. In that case, I went to layout, add page. So now I can add another page or multiple pages with a certain dimension. So these are related to the internal plotter. In an orientation, landscape of portrait. And then in the end, of course, we have to export our model. You can export as PDF, for example. So let me export the current result as a PDF, go to a certain location, and I can save it. And then I have the option to set the quality parameters of my PDF. But in this case, I will just export everything. And if I go to my desktop and I open the PDF, my result will be indeed the PDF with my orthophoto DEM that I just quick and dirty visualized here in this map or map visualization. So actually you can make several pages for this cartographic representation referring to different map teams, the map teams that you defined in your map viewer in QGIS, and based on that you can modify the content of your information. There are multiple exporting functionalities, so you can just export your entire document as a PDF or map series, but also in several raster-based and vector-based image formats. So that's what you see here, for example. the ability to export as an image. So for image exporting, you have to define your export resolution with the page width and the page height, and then you can decide to export several PNGs or JPEGs for your cartographic result. A nice example of this map composer. It has nothing to do with photogrammetry, but I really don't want to. I really want to show it to you. I think it is Landgoederen Vlaanderen Atlas. I think it's this one. This one. This is, at least from my perspective, a very interesting application of using the map composer. To show you that's quite a powerful tool. I hope it's this one. Yeah, it seems so. Yeah, voila. So the Department of Landscape Sciences asked me to make a composition of several landscapes in the Flemish region. So that's what I did here. I made 2 pages, and behind these 2 pages is actually an atlas that I will activate, hopefully. Preview atlas. And the different pages of this atlas are actually referring to a shapefile. So scattered all over Flanders, there are quite a large number of historical landscapes. And all these different landscapes are automatically, for each landscape, I automatically assign some historical cartographic information, some administrative information. So here we are in Gravensteen in Ghent, the Arenberg Park of the University of Leuven. In this case, Nachtegalen Park in Antwerp. Just to give you some information of the very interesting potential of the print composer in QGIS. It's of course in Dutch. But you can also do that, of course, with your own data, your own orthophotos and digital elevation models, accompany them with the spatial data infrastructure or implement them in the spatial data infrastructure that you have for your own archaeological or cultural heritage projects. And then you can actually bring all these data together and make very nice cartographic publications of it. But this is just for your information. Voila, that's what I wanted to show you for the last part of this session. I hope it was a little bit behind the scoop of photogrammetry, of course. But I hope you liked the content of it. Don't know if you have any questions so far. In that case, let me go to the Moodle platform. This is GIS. Let's go to photogrammetry. As I promised, I didn't mention it. Yeah, I have to make this visible, of course. Edit view topic. So here you can find the presentation that I gave you today about publishing 3D models using using Agisoft or using photogrammetry. So you can find it here. As I promised, also you can find some videos about assigning ground control points, exporting your data to digital elevation models, orthophotos, and some more background information also about the processing report or quality report that's here under at the end of the Moodle platform. I think it will be very interesting for you to try to publish your data. I will send you via WhatsApp the login information. So I will give you my email address and my and the passwords that I generated for the Heritage account. It's a temporary password and a temporary username, of course. We will change that after the course. And I would like to invite you to upload your models. As you have seen, and it's also referring to the question that was asked by Thomas. If I go to my platform again, or to my repository again, you see that the model that I just uploaded is not published. And also in my own repository, I have multiple objects that are not published so far. So here you have the option to publish or not to publish your 3D model. In this case, it's just in our, let's say, in our repository. And if you really don't want to share your model with the public, then yeah, you can decide not to. At the end of the at the end of the workshop, the models that are not published will be removed. So I will only use them for evaluation. And I will delete them as soon as possible. But of course, if you want to publish your model, if you want to keep your 3D models also as some kind of a promotion material for the partners of the project, then I would really like to encourage you to allow us to publish it. So, but I want to keep that for you, or the option. I want to give you the option to publish or not to publish it. So again, if you don't want to publish it, or it's still here in publish mode, then we will remove it after the summer school, and I will only use your model for evaluation. Meanwhile, I also had a discussion about, during the break, I had a little discussion about the privacy issues and the rights of publishing 3D models of archaeological sites or artifacts or something like that. And apparently it's it's something, a legal issue that is dealt country by country. So in several countries, you can just make pictures and put it on Facebook or Instagram or whatever. And other countries, even in Europe, there are some countries that are more strict on doing that. So for example, in Mexico, or in Greece, to the extent of my knowledge, it's quite difficult to get permission for making pictures of sites and publish them. So it's a very difficult legal issue. I'm not an expert in it, and especially if you're not just making pictures for pictures and for Facebook, but you're making pictures for 3D modeling, even for recreational 3D modeling, like I'm doing, then it's also worth a discussion. So I will continue that discussion, and as soon as there's more information out about it, I will try to share that information with you. But once again, it's a very interesting topic that I'm personally not very well informed about. So I will stop the recording again.